Aucanquilcha. Aucanquilcha, pronounced Aucanquilcha, is a massive stratovolcano located in the Antofagasta region of northern Chile, just west of the border with Bolivia and within the Alto Loa National Reserve. Part of the Central Volcanic Zone of the Andes, the stratovolcano has the form of a ridge with a maximum height of 6,176 meters, 20,262 feet. The volcano is embedded in a larger cluster of volcanoes known as the Aucanquilcha cluster. This cluster of volcanoes was formed in stages over 11 million years of activity with varying magma output, including lava domes and lava flows. Aucanquilcha volcano proper is formed from 4 units that erupted between 1.04 to 0.23 million years ago. During the ice ages, both the principal Aucanquilcha complex and the other volcanoes of the cluster were subject to glaciation, resulting in the formation of moraines and cirques. The cluster has generated lava ranging in composition from andesite to dacite, with the main volcano being exclusively of dacitic composition. Systematic variations in temperature, crystal and biotite content have been recorded during the evolution of the cluster. At Aucanquilcha volcano there is some fumarolic activity, and sulfur deposits are found at the summit. Several sulfur mines lie in the complex. One mine at an altitude of 5,950 meters, 19,520 feet, was opened in 1913 and remained in use from 1950 to 1992. It was the world's highest mine during that period. Originally, sulfur obtained at the mine was transported down with llamas. Subsequently, an aerial cableway was employed to transport the sulfur to the town of Aucanquilcha. To bring the sulfur down, a road network to the summit was constructed in 1972, although it is now impassable. In 1986, 4 men were reported to be living at an altitude of 5,900 meters, 19,400 feet, making them the highest permanent residents on Earth. Geography and Geology. Regional setting. Main articles: Andean Volcanic Belt and Altiplano Puna Volcanic Complex. Aucanquilcha is part of the Central Volcanic Zone, CVZ, of the Andes, a highly silicic volcanic zone in South America. The CVZ generates magmas at a rate of 0.11 cubic kilometers per millennium, 0.026 cubic miles per millennium, 1/10 of the global average of arc magma production, and lies about 135 to 180 kilometers, 84 to 112 miles, above the Wadati-Benioff zone. The arc has migrated eastward towards the high Andes from the Pacific Ocean coast since the Jurassic. The arc contains andesitic volcanoes, ignimbrites and compound volcanoes and has generated over 3,000 cubic kilometers, 720 cubic miles, of eruption products over 28 million years. The Aucanquilcha complex lies northwest of the Altiplano Puna Volcanic Complex, APVC, a local large igneous province. The APVC is underpinned below at a depth of 20 kilometers, 12 miles, by a slow seismic velocity zone that has been linked to the presence of 15 to 25% of partial melts in the zone. The Aucanquilcha complex is much smaller volumetrically than the APVC ignimbrites, but the duration of activity and the location indicate that Aucanquilcha is a subcomponent of the APVC complex. The long-term magma output of Aucanquilcha is comparable to the magma output of other long-term active volcanoes in the central Andes such as Lake and the Uaco. In all such cases, an early peak in magma output is followed by later lower volume activity, 0.1 to 0.2 cubic kilometers per millennium, 0.024 to 0.048 cubic miles per millennium, followed by 0.01 to 0.02 cubic kilometers per millennium, 0.0024 to 0.0048 cubic miles per millennium. Unzen in Japan and Mount Duff and Lawson Peak in California have similar eruption histories. Such decreases may occur because of the lithostatic load imposed by the edifices on the magma chambers and the increased travel distance of the magma through the edifice. Local setting. Aucanquilcha is part of a cluster of volcanoes located between the Rio Loa and the Chile-Bolivia border. Aucanquilcha sits on top of a 2.7 to 3.3 mi andesite platform and rises more than 1,400 meters, 4,600 feet, over it. The main volcano is composed of an east-west 8-kilometer, 5.0 miles, long chain of stratovolcanoes and has an estimated volume of 37 cubic kilometers, 8.9 cubic miles. The maximum slope of the summit area is 25 degrees. During the Cumbre Negra stage, a pyroclastic flow occurred on the northwestern side of the volcano. It covered 34 square kilometers, 13 square miles, on a run of 10 square kilometers, 3.9 square miles, and now has a volume of 0.3 cubic kilometers, 0.072 cubic miles. It was at first identified as a debris avalanche, but the lack of hummocky topography and the presence of large juvenile blocks identify it as a pyroclastic flow. One block in the flow and the lava dome from which the flow originated have been dated at 0.6 Maya. Lava flows, mostly from the summit areas, are dark to gray in color and extend as far as 2 to 3 kilometers, 1.2 to 1.9 miles, from their vents. It is likely that two small lava domes, Cerro Cumbre Negra on summit 5867, on the northwest flank occupy flank vents. To the north lies the 3.3-mile-old andesite Cerro Tres Manos Ridge, to the west lies the east-west Cerro Poland and La Luna Ridge. The volcanic cluster of which Aucanquilcha is a part contains about 19 to 20 volcanoes and has generated about 340 cubic kilometers, 82 cubic miles, of andesite and dacite over 11 million years. Covering a surface area of 700 square kilometers, 270 square miles, the cluster is surrounded on its northern, western and eastern sides by salt flats and alluvial deposits. On its southern side lies the Cerro OW-kahn-KEEL-chuh volcano. The cluster lies on a 70-kilometer, 43 miles, thick crust, and arid conditions since the Miocene have preserved its structures. Its volcanoes are arranged in north-south and northwestern alignments, which may indicate a rupture of the crust above shallow magma reservoirs. Aucanquilcha underwent a northwestward flank collapse, generating a debris avalanche deposit. The debris avalanche descended 2,100 meters, 6,900 feet, and ran for 17 kilometers, 11 miles, with an azimuth of 211 degrees, eventually covering an area of 59 square kilometers, 23 square miles. The flow was channeled between Minho volcano and Cerro Cumbre Negra, an eroded lava massif, towards the dry Rio Loa Valley, favoring the preservation of the slide deposit. The proximal parts of the slide are covered by younger eruptive products and also by moraines, indicating that the slide was followed by at least one glacial episode. The slide lacks the hummocky topography usually found on debris avalanches but has radial ridges and grooves. Another landslide occurred during the Redondo stage on the eastern side of the main volcano into the Salar de Carco. It has the classic hummocky topography of landslides and covers a length of 17 kilometers, 11 miles, and a surface area of 35 square kilometers, 14 square miles, roughly half of the surface area of the Mount St. Helens avalanche of 1980 and one-third of the surface area of the Lake avalanche. A volume of 0.35 cubic kilometers, 0.084 cubic miles, is assumed based on a probable thickness of 10 meters, 33 feet. Petrographically, the composition of the cluster ranges from andesite to dacite with CO2 ranging from 62.8% to 65.7%. Andesites appear as lava flows while dacites form lava domes and dome complexes. The rocks from the main Aucanquilcha volcano are uniformly dacitic and show little evidence of temporal variation in their composition. Potassium content ranges from 1.5 to 4%. Plagioclase is the dominant component of the magma. Clinopyroxene plus orthopyroxene plus amphibole, hornblende and pargasite, or amphibole plus biotite plus minor amounts of pyroxene are subordinate components. Apatite, ilmenite, magnetite and zircon can also be found. There's evidence of magma mixing and mingling. Rocks have a porphyritic texture. Basaltic andesites typically contain less than 10% crystals while dacites generally have more than 20% crystals. The Aucanquilcha group lavas of the first 1 million years are crystal poor and lack biotite. Later lavas contain biotite and more crystals. Based on geothermometric data, the highest temperatures occurred during phases of high activity and lower temperatures are associated with low output periods. It is likely that crustal feedback and increased deep crustal influx of mantle-derived basalts drive increased magmatic flux. During the time of the Poland eruption on the west flank, magma output was spatially segregated with the peripheral Minho volcano generating andesite lavas and the more central volcanoes generating dacites. Various parts of the main volcano have been subjected to hydrothermal alteration. The Azufrera stage edifice was subject to the most alteration. Especially in the summit area and between the Angulo and Azufrera summits lie sulfur-rich talus deposits. The central part of the complex is heavily altered by fumarole activity. Hydrothermal alteration may be driven by the formation of a deep magma reservoir and resulting hydrothermal circulation in overlying rocks. Eruptive history. Eruption rates increased 6 million years ago, coinciding with magmas becoming more uniform in composition and the onset of strong hydrothermal alteration. It is possible that solidification of magmas below the volcano insulated the feeding channels from heat loss and caused the temperatures in the system to increase. Activity waned again 2 million years ago, with magma and included crystals being drawn from depths of 3 to 23 kilometers, 1.9 to 14.3 miles, and forming the Aucanquilcha volcano proper. The 10 million year duration of activity of the Altiplano Puna volcanic complex systems is comparable to the duration of Aucanquilcha activity. The age of the lava flows ranges from heavily glaciated andesite flows overlying less eroded ones to possibly post-glacial lava flows that may be tens of thousands of years old. Aucanquilcha cluster. The Aucanquilcha cluster formed in 4 stages, each corresponding to a group. The Aucanquilcha group, with 7 volcanoes, is constructed from pyroxene, andesite and dacite and formed 11 to 8 Maya. It is constructed from 2 northern composite cones, Aucanquilcha and Volcán Tuco, also known as Cerro Garage, dated 10.96 to 10.51 Maya, and 5 lava domes on the northeastern side of the cluster. Aucanquilcha has a large breach on the southern side of its crater that is likely the product of a flank collapse, but the avalanche deposit may be buried beneath younger material. Lavas within the breach are dated 10.78 to 10.43 Maya. The centers of Volcán Tuco and Aucanquilcha are heavily eroded, and Aucanquilcha's lavas and scoria lie on top of Tuco. The Ugina ignimbrite was erupted 9.4 Maya from an unknown vent and has a volume of 2 cubic kilometers, 0.48 cubic miles, of dacite. While the vent location is unknown, the composition of the ignimbrite, and its dating and distribution, indicate an association with this group. The domes are poorly researched, with the Coscolito dome dated 8.9 to 8.7 Maya and Cerro Amicha 8.01. The total volume of this group is 46 cubic kilometers, 11 cubic miles, indicating a flux rate of 0.013 cubic kilometers per millennium, 0.0031 cubic miles per millennium. The Gordo group, which erupted 6 to 4 Maya following a probable 2 million year hiatus, is located in the southern and western parts of the cluster. Cerro Gordo itself, 5.49 Maya, has a crater that is breached westwards, exposing about 12 radial dikes but with no trace of a debris avalanche. One of the larger centers of the cluster, Gordo, is associated with a lava field on its western side that is dated 4.9 Maya. Cerro Puquios and Cerro Negro, 5.81 to 5.28 Maya, lie on the southern side of the cluster, and glacial cirques cutting their northeastern flanks reveal layers of scoria and lavas. Puquios has an amphitheater structure on its western side. Paco Paco, 4.41 to 4.27 Maya, is located north of most Gordo group volcanoes. It forms a 4 kilometers, 2.5 miles, wide stratocone with a lava-filled crater, and layers of scoria and agglutinated lavas dip from it. Volcán Pabellón, 4.14 to 4.12 Maya, sits southwest of the Puquios Negro Ridge. The Las Bolitas lava field, 5.23 to 5.13 Maya, is associated with the Gordo group but the vent locations are unknown. The total volume of this group is 55 cubic kilometers, 13 cubic miles, indicating a flux rate of 0.027 cubic kilometers per millennium, 0.0065 cubic miles per millennium. The 3.6 to 2.3 Maya Poland group, with 10 dispersed volcanoes including Minho volcano, is the largest group in the cluster and includes Tres Manos, La Luna, Cerro Poland, Che Yuri, Minho volcano and the lavas of the Aucanquilcha platform. Cerro Poland's, 3.5 to 3 Maya, eastern side is deeply dissected, and the exposed materials are heavily altered in the deeper sections. Lava fields to Poland's west and southwest, 2.6 Maya on one western field, are associated with it. La Luna, 2.97 to 2.57, lies just east of Poland. These 2 volcanoes were probably one volcano in the past. La Luna has a lava dome surrounded by a glaciated but unaltered lava table. Cerro Tres Manos, 3.4 to 2.78 Maya, forms a northbound 14 kilometer, 8.7 miles, long ridge with at least 6 vents. Hydrothermal alteration has affected some lavas and pyroclastics from Tres Manos, and the western side has lateral and terminal moraines. The Aucanquilcha platform, 3.6 to 2.7 mi, sits underneath the main Aucanquilcha volcano, and its lava mostly flowed north. Its southern side is a 4,500 meter, 14,800 feet, table with one hill, Cerro Campana, dated to 3.3 mi. The platform presumably forms 1/3 of the total volume of the Aucanquilcha cluster and may have originated from a part of the ridge of the La Luna Polan trend, now buried beneath Aucanquilcha. Chahuri, 2.39 mi, is a lava dome with moraines and 2 short lava flows. It is the youngest Polan group volcano. The total volume of this group is 154 cubic kilometers, 37 cubic miles, indicating a flux rate of 0.077 cubic kilometers per millennium, 0.018 cubic miles per millennium. After the 4 main phases, some scoria cones of basaltic composition, including Pornita and Luna de Tierra, formed between Aucanquilcha and the lake. Aucanquilcha proper. The main Aucanquilcha volcano formed in 4 stages. Between 1.04 to 0.92 mi, the bulk of the volcano formed in the Azufrere stage. One lava flow toward the southwest is unusually long at 6 kilometers, 3.7 miles. A vent at 6,116 meters, 20,066 feet, altitude fed most of this edifice. A second vent on the northern flank at the 5,887 meters, 19,314 feet, summit generated 3 lava flows, 2 shorter ones and a long one to the northwest. The Azufrere stage lavas are blocky deserts with large clasts and flow fronts up to 20 meters, 66 feet, high. These flows are moderately altered and have oxidation rinds. There's little evidence of explosive activity, but it may have been obscured by glacial erosion. The total volume is 21.1 cubic kilometers, 5.1 cubic miles, indicating a flux rate of 0.16 cubic kilometers per millennium, 0.038 cubic miles per millennium. This volcano was probably an isolated cone, but the existence of a previous stage cannot be excluded. The second stage, named Redondo, lasted from 0.95 to 0.85 mi. It formed on the eastern slopes of the Azufrere volcano, with one vent at the 6,073 meters, 19,925 feet, summit. Redondo stage lavas are blocky and platy and usually thicker than Azufrere stage lavas. Some of the summit vent lavas are among the most vesicular of this stage. They are also less weathered. Oxidation rinds are circa 1 cm, 0.39 in, thick, and less subject to sulfateric alteration. The Cerro Chinchilla's lavas are the oldest of this stage, erupted from an unknown vent. They lack amphiboles. The total volume is 9.1 cubic kilometers, 2.2 cubic miles, indicating a flux rate of 0.09 cubic kilometers per millennium, 0.022 cubic miles per millennium. A flank collapse, possibly triggered by a large earthquake, occurred during this stage. The third stage is the Cumbre Negra stage, named after the westernmost summit and principal vent of this stage, Cerro Cumbre Negra, 5,670 meters, 18,600 feet. The time course of its activity is less defined than the previous 2 stages. It may have occurred between 1 to 0.47 mi, but most likely 0.6 to 0.5 mi based on potassium-argon dating. 4 lava flows derived from the main vent, all less than 1 kilometer long and 40 to 60 meters, 130 to 200 feet, thicker than previous stages. They all have hydration rinds but no native sulfur deposits. This stage generated Aucanquilcha's only pyroclastic flow during a lava dome collapse has occurred on Merapi in Indonesia. The total volume of this stage is 0.7 cubic kilometers, 0.17 cubic miles, indicating a flux rate of 0.005 cubic kilometers per millennium, 0.0012 cubic miles per millennium. The youngest stage, known as Angulo, lasted from 0.66 to 0.24 mi. It was centered between the Azufrere and Redondo stage edifices 0.35 to 0.23 mi. Most lava flows from this stage originate on a 1 kilometer, 0.62 miles, long ridge that includes Aucanquilcha's high summit. One crater on the northeast side of the ridge fed lavas to the north. Other than that, most flows extend southwards 4 to 9 kilometers, 2.5 to 5.6 miles, from the vent, and with the exception of a due south flow 50 meters, 160 feet, thick they are thin, with thicknesses of 15 to 20 meters, 49 to 66 feet. One of the oldest flows has been compared in length to the 50% longer geodacite flow but is much thinner. The flows from this stage are weakly weathered and partially overly glacial deposits. The total volume is 5.8 cubic kilometers, 1.4 cubic miles, indicating a flux rate of 0.015 cubic kilometers per millennium, 0.0036 cubic miles per millennium. The volcano has active fumaroles, though the low-temperature fumaroles are not visible through short-wavelength infrared data from satellites. Fumarole activity was observed in 1962. Glaciation and hydrology. The volcano is currently not glaciated despite its height, due to the aridity of the climate. The Quebrada de Chiguire Valley originates at the foot of Aucanquilcha. The Rio Loa River drains the western and northwestern sides of the volcano. The eastern side drains into the Salar de Lage Salpan, the northeastern into the Salar de Laguani, and the southeastern into the Salar de Carcote. Most valleys only intermittently transport water, if at all, but it forms the headwaters of the Rio Loa. The volcanic cluster was modestly glaciated during the Quaternary, as evidenced by glacial striations in moraines at elevations above 4,500 meters, 14,800 feet, and shows evidence of glaciers both on the main volcano and its subsidiaries. At least two distinct glacier stages took place. The western Azufrera edifice was heavily glaciated in the past. At least 3 moraine stages have been mapped on that edifice, and on its southern side is found a modest cirque with glacially polished lavas on the floor. The Redondo stage edifice has several moraine stages on its southern slopes. Another small cirque with a moraine has been found in the northeastern side of the Cerro Cumbre Negro summit next to an Azufrera stage lava flow. A small moraine lies on the south side of the Angulo edifice, some lavas from that edifice overly glacial deposits. Human activity in mining. A famous mine at 5,950 meters, 19,520 feet, altitude that yielded ore with 30% sulfur was opened by Julian B. Carrasco in 1913, who subsequently established the Compañía Minera y Azufrera Carrasco S.A. in 1933. The sulfur was transported down first with llamas, later through an aerial cableway system from El Angulo Station to Amicha Station and finally by trucks. The sulfur was then transported to Chuquicamata to be converted into sulfuric acid or to Antofagasta to be shipped. The mine was active from 1950 to 1992. The last reported mining activity on the mountain was in 1994. In 1977 other sulfur mines were present to the west between Cerro Polan and Cerro Gordo and south of the main Aucanquilcha Massif. The cableway, of which ruins are still standing, runs from the mine to a mining camp, 5,300 meters, 17,400 feet, and from there to Amicha, 3,900 meters, 12,800 feet, where the sulfur was refined during the 1950s. The road leading up to the mine is dated 1972 and is now impassable because of rock falls. There is still a relic network of roads leading up to 5,900 meters, 19,400 feet, as well as ruins of the Amicha and El Angulo stations. Covalite and other copper sulfides found in the area appear to have formed through post-volcanic epithermal mineralization above deep porphyry copper mineralization. The sulfur itself formed at temperatures of 450 degrees Celsius, 842 degrees Fahrenheit, in a now extinct fumarole. Altitude and habitation. The sulfur mine is notable for being the highest mine in the world at 5,950 meters, 19,520 feet, in the highest permanently inhabited area. An expedition in 1935, part of the International High Altitude Expedition, found that miners lived at an altitude of 5,300 meters, 17,500 feet, in the town of Quilcha and reached the higher mine on foot. The expedition found that an even higher abandoned village at 5,639 meters, 18,501 feet, existed, but miners refused to live there. The conclusion taken from the expedition was that 5,334 meters, 17,500 feet, was the highest habitable altitude. Weston 1986 reported that a few miners permanently lived in the mine area. A small group of men, caretakers of the mine, has lived at an altitude of 5,900 meters, 19,500 feet, in a galvanized iron hut. One of them reportedly had spent 2 years there. These are considered to be the highest human inhabitants on Earth. Research performed on Aymara miners of the Aucanquilcha mine indicates that they are fully acclimatized to the altitude, with less hyperventilation and higher hemoglobin than acclimatized people from lower areas. Their families are born and raised at lower altitudes, however.